My friend Steve asked me, what would happen if we dropped a ball, or anything else, into a tunnel that goes straight through the Earth from the North Pole to the South Pole? To answer this question, we'll actually use Steve himself for the experiment.
Let's assume the tunnel has no air and no friction, a perfect vacuum. At first, Steve starts falling freely, pulled toward the center of the Earth. But here's the interesting part. The closer he gets to the center, the weaker gravity becomes. But why?
Because gravity comes from all the mass of the Earth pulling toward its center.
But Steve doesn't stop there. By the time he reaches the core, he's traveling at about 8 kilometers per second. So he shoots past the center and continues toward the other side of the Earth. Then gravity slows him down, pulls him back, and he falls again. If the tunnel is a perfect vacuum, Steve would keep oscillating like a pendulum forever, always reaching the same height he was dropped from. According to scientific calculations, if the Earth had a uniform density, traveling from one end to the other would take about 42 minutes. But Earth's density isn't uniform. It changes with depth. Using seismic data, physicists calculated that the real travel time would be about 38 minutes and 11 seconds. Just imagine traveling the equivalent distance of New York to London in only 38 minutes. Steve's speed is insane, right?
Of course, this whole scenario is completely hypothetical. We can't actually build a tunnel through the Earth. The core is thousands of degrees hot. The pressure is unbelievably high. And without a vacuum, air resistance would stop Steve almost immediately. Still, as a thought experiment, it's one of the coolest physics scenarios you can imagine.